Alright, number 1. Alice bought 8 notebooks for $28.40. If she solves the equation 8x equals $28.40, she can find the price per notebook. What does one notebook cost? So remember that per means for one, and it basically tells us all we have to do is just solve our equation. 8x equals 28.4. So remember, our goal when we're solving an equation is to always isolate the variable. We want to get x by itself on one side of the equal sign. So we always start with the side with the variable. Ask yourself, what operation is happening? 8x means 8 times x. The opposite of multiplying is dividing. So I'm going to try to get rid of that 8, so I'm going to do the inverse operation. I'm going to divide by 8 on both sides. Remember, with an equation, whatever you do to one side, you have to do to the other. 8 over 8 is just 1. So I'm left with 1x equals 28.4 divided by 8, which is 3.8. So this means that one notebook costs $3.80. So I'm going to go over to my griddable. It's very important that you make sure that you put your numbers in the correct spot and you shade in the correct bubble. Number 2, solve 55 is greater than or equal to 39 plus m. Graph your solution. So I'm going to go ahead and write my inequality. So just like an equation, whenever we're solving an inequality, we're still trying to get the variable by itself on one side of my inequality symbol. We're going to do the same exact steps as we would with an equation, and we're going to solve. So this is a positive 39. So that's like I'm adding 39. The inverse operation of adding 39 would be to subtract 39. So I'm going to take away 39 from both sides of the inequality symbol. 39 minus 39 is just 0. So I'm going to bring down my variable, bring down my inequality symbol. 55 minus 39 is 16. And the last step is to graph my inequality. So because we're used to reading our inequalities from left to right, I'm going to go ahead and I'm going to switch it around because that's going to help me whenever I am graphing it. So I'm going to read it backwards. So I have m is less than or equal to 16. So now that I have the variable on the correct side, I'm going to go ahead and graph it. So I know that 16 is going to be on my number line. M can be any number that is less than or equal to 16. So ask yourself, can M equal 16? Yes, so 16 is a solution for M. Alright, now I need to figure out which way I'm going to point my arrow. If M has to be less than or equal to 16, I'm going to point my arrow to all the numbers that are less than 16 on my number line. If we wanted to check it, we could just pick a number on our line here. So if I picked 15, for instance, since 15 would be on our little line that we drew, is 15 less than or equal to 16? Yes, so that I know that I pointed my arrow in the correct direction. Alright, number 3, Samuel's family purchased $189 in supplies for his graduation party. They have a party budget of $300. Write an inequality to find T, the amount of money they have left to purchase the rest of the supplies. Okay, so first we need to figure out what inequality symbol we're going to use. They have a budget of $300. Okay, so that's what my total is. So my inequality, the amount of money that they have to spend, their budget, has to be less than or equal to $300 because they can spend $300, but they can't go over. So it has to be less than or equal to. So once we figured that out, it says that the family purchased $189 in supplies already. So we want to know what we could use to find T, the amount of money they have left. So the amount of money they have left plus how much they've spent already has to be less than or equal to $300. And there's my inequality. There is another way that we could have written this. You could have said that the amount of money they have to spend has to be less than or equal to their total budget that they have minus how much they've already spent. So either one of those would work for this problem. Alright, so number 4, you should have drawn your TPV table. We're trying to find a relationship between my x and my y, so I'm going to go ahead and start filling out my TPV table. Remember, the T stands for term, and that is all my x values. So I have 1, 2, 3, 4. And remember, the whole goal of filling out our TPV table is to find the process or the rule for the table. So now I'm going to go ahead and put in my values or my y's. This is my dependent variable. Step 1 is to always write your terms in the process column in parentheses. Once we do that, if our x's, our terms, are in consecutive order, then we can find the relationship or the change in y. So I'm going to look at my values. How do you go from 2.5 to 5? Well, you add 2.5. How do you go from 5 to 7.5? You add 2.5. How do you go from 7.5 to 10? You add 2.5. It is the same every time. We're adding 2.5. I'm going to circle that. And this number is going to go in my process column before my terms in parentheses. All the way down. So once we have this filled out, we need to check it to see if it works every time. So I'm going to start here with 2.5 times 1 is 2.5. That works. 2.5 times 2 is 5. That's correct. 2.5 times 3 is 7.5. 2.5 times 4 is 10. So we found our rule that works every time. We're trying to find an expression, so I don't need to write an equation. I just need to write my rule, which is right here. 2.5 or 2 5/10 x. That is my rule for this table. Number 5, what expression is not equal to the model? So first, before I can solve this, I need to figure out, well, what exactly is this picture modeling? So there's different ways you could do this, but what I see whenever I look at this is I see that I have two groups of 2x minus 2. So I'm going to go ahead and write that over here. Two groups of 2x minus 2. So I know that I'm going to be using the distributive property here. So I'm going to distribute that 2 to everything inside the parentheses. So to do that, make sure that you draw your arrows. 2 times 2x is 4x. 2 times negative 2 is negative 4. So I need to figure out which one of these answer choices is not equal to what I have in my model. So let's look at answer choice A. I have to distribute. Remember, if we distribute to one thing inside of our parentheses, we have to distribute to the rest of what's in the parentheses in order for it to stay equal or to be fair. So 4 times x is 4x. 4 times negative 1 is negative 4. So that is exactly what's modeled in my model up here. I have 4x and I have negative 4. So that's not my answer. Let's look at B. We have 4x. The only thing we're distributing is this 2. So 2 times negative 2 is negative 4. This is what is modeled by our model that we have. Let's look at C. Distribute the 4 to the x. 4 times x is 4x. 4 times negative 2 is negative 8. I don't have negative 8 in my model, so that's looking like that's going to be my answer. Let's just look at D just in case. 1/4 times 16x is 4x. 1/4 of negative 16 is negative 4. That is what is modeled, so C is my answer. Number 6, label the statements below as either an algebraic expression or equation. So let's look at A. A says the quotient of a number in 12 is 2. Now, I don't have to write the actual equation or expression, but I'm going to go ahead and do that just to show you. But I know that this keyword here is, that means equals. So I can automatically say that this is an equation, but let's look to see what that equation would look like. So I know that quotient means the answer to a division problem. So the answer to a division problem, so of a number and 12, so x divided by 12 is, so that equals 2. Okay, this equal sign means that it is an equation. B, so that's A. B says a number and 5. So all this means is we have a number and 5. Okay, there is no equal sign, so that would be an expression. Okay, let's look at C. Double a number. So double a number, that means 2 times a number. If we doubled a number, we'd multiply it by 2. Less 3, so minus 3 is, there's that key word, is equal, equals 8. Okay, this equal sign here tells me that that is an equation. D, the difference of 6 in a number. So difference of 6 in a number. The difference of 6 in a number. So I know I have a subtraction problem. I don't know what that equals. I don't know what the difference is. It doesn't tell us. So that is an expression. Number 7, use the table to the right to identify the best verbal description. To help, use the phrase blank depends on blank. So let's look at our table. We have the number of items and the cost. So I need to figure out, does the number of items depend on the cost, or does the cost depend on the number of items? Alright, so which one sounds better, or which one sounds correct? So it should be that the cost depends on the number of items. So it's just like if you go to the grocery store. Your total cost is going to depend on the number of items that you purchased. So let's look at our answer choices to find the best description. A says the cost is dependent because it's on the bottom row. Well, the cost is on the bottom and it is dependent, but I don't really know if that's a good reason for why it's my dependent. So I'm just going to kind of put a little star by it. Maybe, probably not though. Let's look at B. The top row is independent because it has lower numbers. Well, the reason that the number of items is our independent variable is not because of these numbers up here. Sometimes your independent variable may have bigger numbers, so I don't think that B is our answer. C says the independent is I, so right here, because it determines the cost. Okay, that sounds like a much better explanation for why the number of items is independent. The number of items determines what the cost is going to be. So the best description would be C. Number 8, what equation best represents the relationship between the independent and dependent values in the table below? Okay, so I know that I'm trying to find an equation. We need to know what the rule is for the table. So I'm going to try to fill out a TPV table. So the input is my X. That is also the terms, or the T. So let's go ahead and put these in. Okay. The output is my V. So I'm going to go ahead and put these numbers. Step 1 is to write our terms in parentheses. All right, step 2 says that if our terms, which are right here, if they're in consecutive order, then we can try to find a rule. But if you notice, we're jumping from 36 to 30. So that's not in order. So anytime this happens, just go back to your table and see if you can find a relationship without using the TPV table. We have not taught you how to do this. You will learn this probably next year. But because we have not learned how to do it, the TPV table, when our terms are not in order, let's just see if we can find it without the TPV table. So let's look at our table over here. We are going from 36 to 12. So if you ask yourself, how can we get from 36 to 12, a lot of you may have noticed that you had to divide x by 3. So we took 36, we divided it by 3, and then that gives me 12. So if my rule is x divided by 3, then it needs to work every time. So let's check it. How do we go from 30 to 10? Well, 30 divided by 3 is 10, so that works. What about 24 divided by 3? 24 divided by 3 is 8. So my equation for this table, just from looking at it and trying to find a relationship without using the TPV table, would be y equals x divided by 3. Okay? You could have also written y equals 1/3 times x. Both of these would be correct answers. If we were to multiply 36 by 1/3, we would also get 12. So, number 9, does this inequality contain negative 25 as a possible solution? So we have negative 6 is greater than or equal to 1/5 x. So that means 1/5 times x. If I want to know if negative 25 could be a possible solution, then I need to substitute negative 25 into my inequality. So I'm going to go ahead and rewrite it. Negative 6 has to be greater than or equal to 1/5 times negative 25. Okay? So if I need to multiply fractions, I'm going to have 1/5, and then negative 25 as a fraction will be negative 25 over 1. Remember, we have to multiply the numerator, so 1 times negative 25 is negative 25. Remember that a positive times a negative is a negative. Multiply your denominators. 5 times 1 is 5. Now I have negative 25 divided by 5. So first, 25 divided by 5 is 5. A negative divided by a positive gives me a negative. So this means that negative 6 is greater than or equal to negative 5. Okay? This is false. If you think about a number line, here's 0, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Negative 5 is closer to 0 on the number line, so negative 5 is greater. So negative 25 cannot be a solution for x. It is false. Number 10, are these two equations the same? Explain your answer. And the answer is yes. I know we've talked about this a few times in class, but anytime you divide a number by something, it's the same as multiplying by 1 over that number. So for this particular example, if we had x divided by 6, dividing by a number by 6 is the same thing as multiplying by the reciprocal, which is 1 over 6. So another way that you could kind of justify this answer is if you pick a number for x and you plug it in. So I'm just going to pick 12 for x. So let's pretend that x equals 12. So if x is 12, then 12 divided by 6, that would equal 2. Okay? So now let's plug in 12 for x over here. So we have y equals 12 times 1/6. Okay, so 12 as a fraction would be 12 over 1 times 1 over 6. Multiply my numerators. 12 times 1 is 12. 6 times 1 is 6. 12 divided by 6 is 2. So y would be 2. So it's the same exact thing. We got positive 2 for our answers for both examples. So dividing by 6 is the same as multiplying by 1/6. Number 11, describe the differences and similarities between two tables of data shown below. Use vocabulary and focus on words like independent, dependent, additive, multiplicative, and rule or expression. Okay, so there are a lot of differences and similarities. So first, let's just look at our table here. So if we look at our table, the price depends on the number of notebooks. So the price is the dependent variable. The number of notebooks would be my independent variable. If you were to find a rule or equation for this, it would be y equals 3x. This is a multiplicative relationship and it is proportional. Alright, let's look at the graph now. Remember, you always graph your independent variable on the x-axis. Your dependent variable is always graphed on the y-axis. If we were to write an equation or a rule for this line graph here, it would be y equals x plus 3. Remember, since we're adding, it's an additive relationship. It is not proportional because this graph does not go through the point of origin. So those are just some differences and similarities. There are multiple answers that you could have come up with for number 11.